Hey guys, this is Fred from Prettyfly Games, and today we're going to continue with our top-down car controller built in Unity. Today we're going to add jumping abilities to the car, and also go through how you can add a jumping effect in general for top-down 2D games, as it's a little bit special. I've also improved the graphics by using free assets from Kenny. So let's go into how you can achieve this jumping effect. So in top-down 2D we have an orthographic camera which doesn't really have any depth. So anything that we change the Y value to will go up, and if we change the Z position of an object it doesn't have any effect because there is no depth really. So we need to find a way to achieve the jumping effect by basically cheating a bit. So when an object is jumping, what really happens to it is that it scales. So when it comes closer to or becomes bigger, it appears that it's closer to the camera, and when it's smaller it appears further away from the camera. So what we do when we are jumping, we're just increasing the scale of the object, and that's it really for the jump effect. But also to really fool the eye in a way, we add a shadow to it as well. So we have a black shadow here, and what we can do as well is we can offset it a little bit, like so, around. Now it appears that the car is actually flying to the eye, but in reality it's just scaled up with a drop shadow that is moved. So this type of effect is something that you can do on any top-down game to get a feeling that an object is flying or jumping. So let's go into the code and see how we can add this. So in Visual Studio we've opened the top-down car controller, and we will start by adding two new public variables, the sprite render for the car and the sprite render for the shadow, so we can control them independently. We will also need something that describes how the jump should look like, and we will use an animation curve for this. And animation curves is a super useful tool in Unity, and we'll go through exactly how they work later on, but it gives us the more control over how it should look when it's jumping. And then we need a state as well to be able to know if the car is jumping or not, because we need different behavior when it's jumping and when it's not jumping. Then we will also need a new function. Let's scroll down, and we will add it as a coroutine. So we call it jump CO, so we keep track that it's a coroutine, and it takes in two variables, a jump height scale and a jump push scale. Coroutines is something that is super useful in Unity. It's like a state machine, and we'll go through exactly why it's useful later on. For now, let's add two more variables so we can control the jump. We'll use the start time, so we'll take the time when it starts, and then we'll use a jump duration. Now we also want to be able to call this function from, let's say, our input handler or anything else in the code. So let's add a public variable jump, which the same input variables, which just starts the coroutine if it's not jumping. Then we need to be able to see how far we have gone in the jump, and we calculate a percentage between 0 and 1 to determine how far we are in the jumping process. And what it does, it takes the time, subtracts the start time, and divides it by jump duration. Then we will get a value between 0 and 1, and just to make sure we're clamping it so it can't go beyond that. So this function will run all the time while is jumping is true, and this yield return null just means that when it reaches this point we give back control to Unity so it can move into the next frame. So this automatically keeps track of all the frames and all of that. So it's like a mini update function in a way. So it runs this part of the code and then it waits until the next frame, and then it runs this part of the code again and waits until the end of the frame. So now we can add the jumping part, or the scale part of the jumping. So we take the car's sprite renderer, the transform of it, and the local scale, and we start with a vector 1 because it's size 1 to start with. And then we add vector 1 and we multiply it by the jump curve, and we are evaluating it with a value between 0 and 1. And then we are multiplying it with the jump height scale. This becomes very easy to understand when we are running the code and what is happening. And the magical part of this is this evaluating of the jump curve, which we'll go through later. Then we need to do the same thing with the shadow, but we are going to make it slightly smaller than the shadow or the car as sprite renderer. And the reason for this is it looks a little bit better in our game. In reality, this is wrong, because as objects are getting higher up, their shadow is increasing. So this value should probably be something larger if you want it to look like in the real world. But for our game, it looks good. You can change it to anything you want for your game. Then we need to offset the shadow, and we do that by offsetting the local position of the shadow with a value of a positive 1 in the x-axis and a negative 1 in the y-axis. And then we are multiplying it with the jump curve, as we did up here. And then we are multiplying it with a value of 3 because it looks good. If you have a larger value, the offset will be larger. So you can change that into whatever you think is suitable for your game. And then we need to be able to detect when we are going to land. And we are going to land when the jump is 100% complete. So then we can break this while function, which will cause it to exit and start over here. So in this part, this is where we are going to control if we are jumping or not. So when we are done with our jumping, we are going to change the state to is false. And we also want to reset some things, like that the car's sprite renderer should go back into 1 again, and we will want to reset the shadow as scale and also the position, so it is directly under the car instead. Okay, so let's or actually we need to start using this as well. So let's go into our car input handler. So in the car input handler, let's detect if we are pressing the jump button, and in that case we are going to call top-down car controller jump, and we'll use actually this is wrong, height scale 1 and push scale 0. So it will just make the car jump upwards and not forward. So let's try it in Unity and see how it works. So in Unity, let's select our car. And I've already added a shadow to it, which is just a fuzzy version of the car, a black fuzzy version. And I've moved some of the particle systems into our particle systems child object. So let's assign this, and we'll start with the car sprite and then the shadow. And then we have the jumping curve. And I will use a slightly different one, which looks like this. And let's zoom out a bit. All right, never mind. So it moves between 0 and 1. So that's our percentage completed. When it's starting here, it's 0% completed. About here is halfway, and here is 1.0. I like this curve, how it looks, because it will start very sharply, so it will jump up fast, and then it will stay at the peak for a short period of time, and then it will move down again. So it's not a proper jump curve in the real world, because it looks something like, or a bit more round like this, but it looks good for this type of game. So you can change this curve into anything, but just make sure that it stays between 0 and 1 on the X scale and 0 and 1 on the Y scale. So let's see if this works. Now if I hit the space button, our car is jumping. It has a very long jump time, 2 seconds, but it is working. So we can drive around and we are jumping. Of course the jump time is very long, and it has some other weird things, like you can pass over a jump and nothing is happening. And also if you jump, the colliders will react. So when we are jumping, we want the collider or the car to fly over the collider. So let's go into the code and change so that's working. But before we do that, we'll add a new script, and we will call it jump data, and it will be attached to the jump, so it can control. If we have a big jump, we want the car to jump higher. If we have a smaller jump, we want the car to jump less high. So let's add that, and then we'll go into Visual Studio. So in the Visual Studio, let's add some information to our jump data. So we call it, we'll add a header called jump info, so it looks neat in the editor. And we'll have the ability to set a jump height scale and a jump push scale. So let's save that, and we'll go back into the top-down car controller again. So let's scroll down, and we will add a trigger. An on trigger enter 2D, which will be the jump. So we will take the jump and we will add a tag to it called jump. So when the car is passing over, this event will be called by Unity. And we know it's a jump, so we will get the jump data, which will be attached to the jump, and then we will jump with the car. If we run this now, the car will detect when it's jumping and perform the jump. But we will change a few things in the jump function as well to make it look a little bit better, and also to handle the case where we are crashing into things while we are jumping. So let's take care of the collisions first. When the car is jumping, we want the colliders to become disabled, so it doesn't collide with anything while it's flying. And how we do that is we take the collider 2D, and we get it from the car when in the awake function. So here we'll add the car collider, and we'll get it in the component children. And then when we are jumping, we want to disable this collider when it's starting to jump. So we will take the collider and we will set it to enabled equals false. And when it's landing again, we want to set it so it becomes enabled again. And we will do that towards the end of the function. So let's look at our change state. We'll add it here. All right. So that solves the problem with the car colliding with other things. You can change this if you want the car still to collide with other cars, because when two cars are flying at the same time, they can overlap now, which is fine in our game. But you may want to change that, and then you will have to use a slightly different approach, but the same technique works. Okay. And the next part is we don't want the car to have a set duration or car jump of 2 seconds. Rather, we want it to be a function of the car's rigid body velocity. So if it's a car going slow, we want it to have a very short jump duration. If it's going faster, we want it to jump longer. Depending on the game you might want to change this so it's a fixed value, so you know when you're jumping over a certain jump that you will make the landing. If you have a poor driver that has a poor car, it means that in some cases he may not be able to reach the sort of the end of the jump that you have designed for in your game. So this is something you need to take into consideration when you are designing your game or having this value. The other part that we will change is the jump height scale, and we will do the same thing there. A car that is driving faster should jump higher, and a car that is driving slower should jump lower. Okay, and then just to be safe, we will clamp it up the scale so it can never go below 0 or above 1. Okay, so let's see how this works in our game now. I've cheated a little bit by adding a jump already, and I've assigned the tag jump to it and also put a collider on it and with a trigger. And we can see that the extent of this collider is this. So when the car is passing through the trigger, it will trigger the jump. And the jump data of this jump is a height scale of 0.5 and a push scale of 0.7. The slightly larger jump has a higher jump scale and a larger push scale. So let's see how that works when we are running the code. So we'll use a little bit speed and we'll jump. And I could pass over this collider. Now that I'm not jumping, I'm colliding with it. So it's all good. The thing that we still are not using is the push scale. So we'll add that, and we also have a little bit of a challenge, and that is when we are landing on top of things. So let's see if I can replicate that. So we'll take our car and we will move it. And if we are landing on top of an object that has a collider on it, like this one, then it will cause a lot of problems, because the car will get pushed out by the physics engine, and it looks weird, especially if the object is large. So let's land, and as you can see, the physics engine is pushing it out. So we will go through how to solve that as well. So in Visual Studio, let's add the small push, and that forces the car to move forward, and we will do it after we have disabled the collider. And what we do is we take an add force, and we use the force mode impulse, and we will take the car's velocity normalized, so we will get the direction of the car, and we will push it with whatever is in the jump scale, jump push scale, and we'll multiply it by 10 because it's a suitable constant for this. You can change that into a larger value, which will cause the car to go even faster. Okay, so that was problem number 2. The other problem is a little bit more complex. So how should we handle the case when we are landing on top of another collider? And I've tried various solutions. But what I found was the easiest way to do this, to handle it, is that we make a small check and see when we are about to land, then we are checking, is there anything under the car? And if there is anything under the car, we make a tiny little jump again. So that way we can jump away from the collider gracefully, and it will not look as strange as when the physics engine is pushing the object away and we have zero control of it. It will just look like the car is skipping above this collider, and then when it's exiting on the other side, it will, well, behave normal and just keep driving. So let's add a check for that. So we will do an overlap circle, and we will check with a radius of 1.5 because that is a suitable size for our sprite and car. And what this function does is it's checking if there's anything under this area over the overlap circle, and we have already disabled our collider so it won't detect the car itself. And if something is below it, then we will say that okay, we are no longer jumping, and we will force it to jump again, and we will use a slightly push effect forward so the car cannot stop and stand still and just keep jumping. So we will push it off the other collider. And this other part of the code, we can just add an else on that and handle it, because then it is fine to land if nothing is below it. Okay, so let's save and try it again. Alright, so let's back up a little bit and we'll drive, and I'll try to jump on this bleacher, and we jumped again and again. So now it worked, and we are not getting this weird physics throwing us off the object, but we are jumping and we are controlling how it works. So I think that's a lot better than having the physics engine throw you off in a random direction. Okay, it's still not perfect yet. We have a little bit of an issue. I'll show you if I can pause it. And we have the car and the shadow. And when we are jumping over things, the shadow should, of course, always be over the object that we are flying over. But right now, if we do like this, we can see that the shadow is actually below the bleacher here, and we want it to always be on top of things. So what we want to do is we want to add a sorting layer in Unity, so that this shadow actually stays in that sorting layer. So I've already added a sorting layer in Unity, and we have the shadow here, which we're changing now. And I've added a sorting layer called flying, and I've added it above the default. So if I change this into flying, then it's above the bleacher, but it's also above the car, which we don't want. So we want to change the car's sprite as well into flying. Now the shadow will be below the car but above the bleacher. So we want to program this in Unity or in Visual Studio so it works. And we also have one little weird thing, and that is when we are jumping, we are getting trail marks all over the place because the trail doesn't really know that we're jumping, so it's emitting trails all the time. So we want to stop it from emitting when we are jumping. So let's also change that in Visual Studio. Now there is some additional things that I forgot to mention. One is that you can now actually brake when you're flying and stop the car, which is something we don't want. So let's check if we are jumping and the accelerator input is below 0, so the person is trying to brake or stop the car, and we just change it to 0 if they are trying to do that. The other part is that we have this limit, so it can't drive faster when we are applying the acceleration, but when we are pushing the car forward, we actually want it to go faster. So let's say that we will ignore this while we are jumping, so we can really get that nice push effect. And that should solve those type of problems. And then we had that our brake system is emitting while we are in the air, which we don't want. So we'll add a test for that. If we are jumping, we will just return false. And that's it to solve those type of problems. Then we had the last part of this, which is the sorting layers. So let's go back into our jump code, And once we have disabled the collision, we want to change the sorting layer of the car sprite renderer and the shadow. And we change it by just assigning a different name, flying in this case. And when we have landed, we want to change it back so it becomes the right sorting layer after we have landed. So let's go into the code and we'll add it after we reset the collider. So now the sorting should work, and that's all good. We can also do a few more things while we are at it. We can add a particle system so that there are a few nice particles that spew when we are landing. So let's add a new public variable, a particle system, so we can start to use that when we're landing. We can throw off a little dust cloud or something. And this particle system should be played when we are landing. And what we can do as well, if we are just having very short jumps, then maybe we don't want that type of behavior. So we can just check if the jump height scale is above a certain value. Then we will do this. If it's not, then we will not play the smoke cloud, because it's jumping just so low that it looks weird. So we'll add the landing particle system. And as well, in the car sound effects handler, we can add a little sound effects, like a sound effect when we are jumping and a sound effect when we are landing. So let's open our car SFX handler. We'll add two new audio sources, one when we are jumping and one when we are landing, and then we will make two public functions that allows us to call this. So we can add it just here. All right. And then in our top-down car controller, let's start using those. So when we are jumping, we want to call the SFX handler, and we will just add it. Oh, sorry. We will add it after we have disabled the controller. All right, I forgot to actually add a reference to that. So let's get it as a variable first. All right, let's go up here and we will add it as a car SFX handler, and we need to get it when we are in the wake function, and then it should work. So we are playing the sound when we are starting to jump, and when we are landing, we want to play the other sound effect, which is a small thump. And we only want to do that if it's a high enough jump, otherwise we will not do it. So we'll use the same thing as the particle system. Okay, so let's assign all of these things in Unity, and we can take it for a final spin. So to speed things up a little bit, I've already added the car jump and landing sound effects. I've added a particle system for the landing, so it looks like that. And I will just hook them up, or actually I already have hooked them up. So we are already using them here. You can see the landing particle system and the audio systems. So now we can take it for a final spin and enjoy our game. So let's back up a little bit, and we have the small jump with a cloud when we're landing, and we can make a higher jump, and we can land on top of things. So that concludes this video. Of course, it's very arcadey. I mean, you can turn when you're jumping, so maybe that's not something you want in your game, so you can change that if you want, but I kind of like it in arcade games, that you can actually turn and jump and do things while you're jumping. You can also brake a little bit, but not stop entirely, so I can make a shorter jump and control that quite nicely. So I hope that you enjoyed this video, and if you do, please give it a thumbs up, and also hit the subscribe button if you want to know, get a notification when the next video is out. Here's an example from our game, Total Arcade Racing, which uses this component. You can find the game on Steam or Nintendo Switch. Please take it for a spin if you want to.